All right, section 10.5, geometry. This is another kind of tricky section, but it's a pretty easy concept if you kind of understand what's going on here. So I'm going to start off by looking at two figures up at the top here. So I have two rectangles. One is labeled as, the bottom side is 2, and the top side or the vertical side is 1. Then I have 6 and 3, okay? So I'm gonna do an example of this so that you can kind of see what's going on here. We'll find the perimeter of this guy and the perimeter of this one, and then we'll do the area for both of them as well. So when we're finding perimeter, okay, we're just adding all 4 sides together. So if this side is 2 and that's 1, this is also 2 and this is 1. Adding those together, I have 2 plus 2 is 4. 1 plus 1 is another 2, so that perimeter is like 6, I think. Okay, this guy, my perimeters, I have this top side is going to be 6, this bottom side's, or that side's going to be 3. So if I add those all up, that's going to be, what, 18, I think? 6 and 6 is 12, 3 and 3 is another 6, so 18, yeah. 18 is the perimeter, okay? So let's look at kind of how this perimeter works, okay? If I look at just starting with this figure and going to this figure, okay? And we find a scale factor, which we did like in chapter 7, I think is when we did 6 or 7 when we did scale factor. Your scale factor is going to be what you end with divided by what you start with, okay? Or basically it's like, how big am I scaling him up to be? Like, what am I multiplying him by? Well, it's kind of easy to see that 2 times 3 will give me 6. 1 times 3 will give me 3. But the reason for that is because 6 divided by 2 is a scale factor of 3, right? And scale factor is 3. So what happens here is that when you're dealing with perimeter, we found the perimeter over here, which was 6. We found the perimeter over here, which was 18. My scale factor is 3. So my perimeter, all I have to do is multiply this guy by 3 to get my new perimeter, right? 6 is my starting. I multiply by 3 to get the 18, okay? But now let's look at a different scenario. Let's look at area instead. So to find area, I take base times height, because this is a rectangle. So 2 times 1 will give me 2 as an area here. If I do my base times height over here, 6 times 3, that's an area of 18, okay? Now, if I look at that, 2 is the area here, 18 was the area here. I did not just multiply that by 3. 2 times 9 will give me 18, right? So what happened here was, rather than taking and just multiplying by the scale factor, we multiplied this by 3 squared, because 3 squared was 9, okay? So when you're doing area, the area will be multiplied by the scale factor squared. So the area equals scale factor squared. That's what he will look like, okay? So what they've done here is, what we can do is area equals scale factor squared. So what we can do is set this up kind of as a proportion here, I guess, when we're looking at our two areas, okay? We can do area start, or area of the first figure, divided by the area of the second figure, or ending figure, is equal to the scale factor squared, okay? So scale factor is represented as like a fraction, something over something. So this would be like a scale factor of 3 divided by 1, okay? The area of something, of the start, wait a second, I didn't want to do that. I want to do the area of the end over the area of the start. End, I did that wrong. End over start, right? It's always where your ending divided by start is equal to your scale factor squared. So we said that 18 was my ending, 2 was my starting. So 18 was my ending, 2 was my starting. That's equal to the scale factor, which was 3 squared, right? 18 divided by 2 is 9, which is the same thing as 3 squared. My area of my ending divided by my area of my starting is a scale factor squared, okay? So hopefully that made a little bit of sense. Let's go down in here and see if we can figure out the area of this guy. So they say here that these two guys are similar figures. Now this only works for similar figures. I didn't say that, but that's what the title of this section is. Only for similar figures. Like if we're trying to compare a circle to a rectangle, that's not going to work. They have to be the same figure and same shape, but different size, okay? So we have these two figures right here. This guy right here is 12, this guy is 15, okay? So we're going from like the 12 guy to the 15 guy, okay? So my scale factor, if I do my scale factor squared, your scale factor is end over start, so it would be 15 over 12, okay? And I'm going to square that guy, okay? So end over start, I have end over start is equal to the scale factor squared, start. It says the area of JKL is 30. So this guy's area is 30. We don't have any of the other dimensions besides that this guy is 12, right? So this guy's area is 30. They want to know what the area of this guy is. Oh man, that's kind of confusing. So we know my starting one, but I don't know my ending one, okay? So ending one, let's call this area question mark. We don't know the ending guy, but we do know the starting guy. We know that the starting guy is 30, okay? So I have this set up. End over start equals the scale factor squared. Okay, we figured out our scale factor. End over start squared. End over start, okay? So if I'm trying to find that area squared, to get rid of that 30 is all I would need to do. I would just multiply both sides by 30, okay? So I'd have 15 over 12 squared equals 30. And let's get a calculator out here. Or not, equals 30 times 30. I'm going to take 15 divided by 12. I'm going to square that. And then take that times 30. 46.88, let's say. So the area of the second one is going to be 46.88 inches squared. Okay, so I set it up kind of like the way that this is. The area of the end over the area of the start is the scale factor, which is the end over start squared. Okay, we'll do a couple more of these, and then hopefully maybe that'll help catch on here. For each pair of similar figures, find the area of the right figure. Okay, so we want to find the area of this guy. We'll call this area question mark again. Okay, area question mark. Okay, so I'll put my equal sign here. Okay, I want end over start. Okay, end over start, end over start, end over start. Okay, so I have the area on this side, and then I have scale factor over here. So I'm looking at my two sides. My ending side over here is 5. My starting side over here is 8. The left side is going to be your start, right side is going to be your end. So I have end over start, 5 over 8 is going to be my scale factor. Okay, 5 over 8 is the scale factor. Then I need my ending over starting. Okay, so ending is going to be a squared, or a question mark. Starting is going to be 32. Okay, so it's just the scale factor squared is equal to this guy. Okay, now just the same way as we did up above here, I have times 32 times 32. So the area question mark, or the area that I don't know, I take 5 divided by 8 squared times 32. I'll put my calculator down here so you can kind of see how I type this in. 5 divided by 8. Okay, I'm going to square him, and I can take him times 32. Okay, that's one way of typing it in. And when I do that, I get 12.5. 12.5 centimeters squared is going to be my area. Okay, if we look at that and see if that seems reasonable, this one is smaller than what the one was before that. So 32 should become a smaller area, 12.5. Okay, all right. Next one here, we want end over start again. Okay, and then my scale factor is over here. We're going to square him. Okay, so my sides or my scale factor here is going to be 8 for my ending. Starting is 6. Okay, you can reduce that if you want to, but it doesn't really matter. Ending area over here is what we don't know, and starting area was 13.5. End over start equals end over start. Okay, so again, there we're going to multiply by 13.5. All right, so 8 over 6 squared, and we're going to times 13.5. Okay, and that gives us 24 exactly. So the area that we don't know is going to be 24 square feet. Let's see if that seems reasonable. We started with an area of 13.5. 24 is the next area. so we made it larger, but we went from 6 to 8. So we were making it larger. We were increasing it. So that kind of makes sense. Okay? All right. Next one. Example 2. The area of ABCD. This guy's area is 150. Okay? And the area of this one is 54. Okay? They want us to find this guy right here, this x. Okay? And then talk about the scale factors. So we need to know what x equals, and we need to know what the scale factor is. Oh, those are two things that we don't know. Okay, so, all right, the way that we set this up, we do end over start. Okay, all right, this is where my scale factor goes, and it's a scale factor squared. And then I have my ending starting area over here. Okay, so my ending area was 150, my starting area was 54. Okay. Now, in this one over here, my ending side length is 10. My starting side length was x. Okay, so he's going to look kind of like that. Okay. Now, we have to do some algebra to get this x solved for. He's a little bit harder than what it was when we were solving for the area over here. Okay. So what I'm going to do is I'm going to take 150 over 54. That's going to stay the same. Well, actually, let's do this. Cross that out. Let's do, what is 150 divided by 54? 150 divided by 54. 2.78, let's say. 2.78. That's what 150 divided by 54 is. Okay. Now, what I'm going to do here is I can take and distribute this 2 through. So this will be 10 squared, which is 100, over x squared. Okay. And now we just have to do a little bit of algebra to switch this guy around. Okay. When you have that x squared in the bottom there, we kind of talked about this before, where those two things can switch places with each other. So it would look like x squared equals 100 divided by 2.78. Okay, and then I would figure out what that is. So 100 divided by this number in my calculator already. So 100 divided by that answer is 36. Oh, that's really nice. And then I would take the square root. So x is going to be the square root of 36, which is just 6. Okay, so x is 6. Okay, and that is 6 meters. So I still set up my proportion or my equation exactly the same as what I did up here. End over start, scale factor squared, except I didn't know this guy down here. That's what I was solving for. Right now, what is the scale factor? Scale factor is the ending side over the beginning side. 10 over 6 is what we just found. Or if I reduce that, that would be 5 over 3. That's my scale factor. Okay? So there he is. Okay? From this guy to that guy, I have a scale factor of 5/3. And x is 6. So same formula the entire time. All right, let's do one. We'll do one more of these. Maybe we'll skip part B, or I'll have you do part B by yourself. Okay? So this one here. Scale factor, then they give me the area. Okay, so end over start. Start, here we go, end over start equals the scale factor, but this guy is squared. Okay, so my sides determine my scale factor, 6 and x. So 6 here and x here, end over start. Okay, my end over starting area here is 72 and 50. Okay, all right, so 72 divided by 50, if I want to convert that to a decimal, I can do that first. 72 divided by 50 is 1.44 exactly. Okay, and then what I'm going to do is I'm going to square each one of these, just like we did before. So 6 squared is 36. X squared just stays x squared. Okay, now to get the x out of there, I'm going to switch these two pieces, just like we did before. So I have x squared equals 36 divided by 1.44. And we'll see what we get there. Okay. All right. If I'm going too fast, go ahead and stop the video if you want to. That's fine. 36 divided by 1.44 is, really nice. X squared equals 25. Okay. So then that means that if I take the square root, x equals 5. Okay. So this guy right here is just 5. Okay, and then do they ask for the scale factor? For each pair of similar figures, use the given areas to find scale factor. Oh yes, scale factor. Okay, so scale factor is just that end over start, like this guy right here. This is what my scale factor is, scale factor squared. So ending number is 6, starting number is 5. 6 over 5 is my scale factor, and that can't be reduced, so that's it. So I found that x was 5 inches, and my scale factor is 6 over 5, going from the left to the right. Now, scale factor, if it's a number that's larger than 1, that means you're enlarging it. So 6 over 5 is a number that's bigger than 1. We are making it bigger, which means we're enlarging it, which is exactly what we're doing. If it was a number less than 1, like 5 over 6, that's a number less than the 1, that would mean that we are making it smaller. That would be if these two figures were flipped around. So if we were starting with the large one going to the smaller one, we would use 5 over 6, because my ending would be 5 and my starting would be 6. Okay? All right, so part B is exactly the same way, so I'm not going to do that one. We'll see if you can figure that one out. We'll see if you can figure that one out. And then we'll skip example 3 also, so this video isn't too terribly long. But this is kind of a hard section, but just remember that this is the proportion that they're set up in. Because you're doing area, and area is squared, you have to take the scale factor and you have to square it to get it equal to the area. Okay?